What if we want the electric motor to rotate in the other direction? We need a reverse, and in order to achieve this we need to go back to the diagram and do something. We see that 3 phases pass through the contactor in series. To achieve a reverse rotation of the electric motor, we need to change the phase sequence. Replacing any 2 phases leads to reverse rotation of the rotor, no matter what. The only correct method is to install another contactor. We supply 3 phases to the input of the KM2 contactor. And at the output we change 2 phases in places. Now phase A and C from the output of the contactor KM2 are fed to C and A, respectively. Let's deal with the control circuit KM2. The KM2 control circuit is no different from the KM1 control circuit. We put the contactor on a DIN rail. We put a jumper on the supply of the A2 coil. We put a jumper on the self-supply of the contactor. Power supply back button. We connect the outgoing wire from the button. When the KM2 contactor is clamped, the power goes through the auxiliary contact and it rises to cell power. We supply power to the KM2 contactor. We put the outgoing wires from the KM2 contactor. The phases passing through the contactor KM2 are reversed and the motor rotates in the opposite direction. Trying ahead. Try back. Sumptuously. And what if we want the light of the pressed button to light up? Thus, we found out in which direction the engine rotates. To do this, connect a light bulb in parallel with the contactor coil. Power supply of AC 220-volt button lamps, so first we connect 0, then we connect the phase. We throw a jumper on A1 in the contact of the button lamp. Check. It seems everything is good. Now attention to what should not be done if you do not have mutual blocking. When the first contactor is closed, the second contactor cannot be closed, because a line-to-line short circuit will occur. To prevent accidental switching on of another contactor, you need to make a mutual interlock. We look at the diagram. The highlighted area always has a phase. The task is to exclude the phase hitting the contactor coil. For this we can use the NC contact of the contactors. NC contact: when the contactor switch is on, it becomes NO and thus breaks the circuit. We will draw the NC contact KM1 on the contactor circuit KM2. To solve our question, we need an additional contact that is inserted into the contactor. It consists of 4 contacts, 2 NO and 2 NC. We check the stroke and the tongue for removing the additional contact. Check it does not jam. On A1 of the KM2 contactor, we must pass the power circuit from the additional NO contact KM2 through the NC contact of the KM1 contactor. To power the KM1 coil, we must pass the additional contact of the KM2 contactor through the NC contact. We make a jumper from the NO contact KM2 to the NC contact KM1. And a jumper from the NC contact KM1 to the power supply of the KM2 coil. The phase will now come from the button to the additional contact KM2 and to the NC contact KM1. If the NC contact KM1 is closed, then it will pass to the power supply of the KM1 coil. We remove the jumper of the KM1 contactor. We make a jumper from the NO contact KM1 to the auxiliary contact KM2 and from the auxiliary contact to the coil KM1. We check it does not seem to turn on. Good. Press the KM1 button and check. Excellent.